For thousands of years, humans looked at the sky and tried to explain what they were seeing. Some people were scared. Some thought it was a sign from the gods. Others created stories to explain it. Before telescopes and satellites gave us answers, people relied on myths and legends. And honestly, some of those stories were amazing. In the Arctic, indigenous peoples believed these lights were the spirits of the dead playing a game in the heavens, using a walrus skull as a ball. In Finland, they call the lights foxfires. The old legend says a magical Arctic fox ran so fast across the mountains that its bushy tail brushed the peaks, sending sparks into the sky. These stories are beautiful, but the real science, even more mind-blowing. To understand the northern lights, we have to travel 150 million kilometers away, to the sun. Every second, it blasts streams of charged particles into space. These particles travel through space at speeds of up to 800 kilometers per second. And they reach Earth in just 2 to 3 days after leaving the sun. If these particles hit Earth directly, they would strip away our atmosphere and destroy all life. But we have a secret weapon, the magnetosphere. An invisible magnetic field surrounds our planet. It pushes most of the solar wind away. But this shield has a glitch. At the north and south poles, the magnetic lines curve inward, creating two funnel-like openings. At these points, the charged particles travel down along Earth's magnetic field lines, straight into the upper atmosphere. That is where the aurora begins. High above Earth, the incoming particles collide with gases in our atmosphere, mostly oxygen and nitrogen. These collisions transfer energy into the gases, but the gases cannot hold that energy forever. So they release it as light. Trillions of tiny flashes happening almost simultaneously create the glowing waves we see in the sky. But the colors depend on the type of gas being hit and how high the collision happens. When particles hit oxygen lower in the atmosphere, the sky glows green. This is the most common aurora color. Higher up, oxygen can produce deep red auroras. These are much rarer. Nitrogen creates blue and purple tones. So when you watch the northern lights dance across the sky, you aren't just looking at pretty lights. You are literally watching a live chemistry experiment happening at the edge of space. Most people know about the northern lights, but at the exact same moment, another aurora is dancing over the bottom of the planet, the southern lights, also known as the Aurora Australis. Both auroras form around Earth's magnetic poles in giant rings called auroral ovals. These glowing rings expand and shrink depending on solar activity. During powerful solar storms, the aurora can travel far beyond the Arctic. So why does everyone talk about the north and ignore the south? It's simply a matter of geography. The northern oval passes directly over populated places with roads, airports, and hotels. The southern oval sits almost entirely over the freezing, empty waters of the Southern Ocean and Antarctica. Seeing the aurora is part science and part luck. The lights are almost always there, but to see them, conditions have to be perfect. First, darkness. The best months are from September to March, when Arctic nights become long enough to reveal the sky. During summer, parts of the Arctic experience nearly 24 hours of daylight. Even if the aurora is active, the sky is simply too bright to see it. Second, solar activity. the aurora becomes stronger during periods of intense solar activity called solar maximum. This happens roughly every 11 years, and right now we are near the peak of solar cycle 25, making this one of the best times in years to witness the northern lights. And finally, clear skies. Clouds and city lights can easily hide the aurora. The darker your surroundings, the better the experience. Aurora hunters also track something called the KP index, a scale that measures geomagnetic activity. The higher the number, the stronger the aurora. Maybe that's what makes the northern lights so special. Not just the science behind them, but the feeling of standing beneath something so much bigger than yourself. And honestly, it's hard to believe something this beautiful is actually real.